Hello, hello! Death! Death! Death. It's a morbid subject, but one I seem to think about pretty much every day. Not in a the end is nigh kind of way, but more as a reminder to focus on what's important and don't sweat the small stuff. Even so, death is one of those facts of life that few people enjoy talking about. Yet, somehow, Halloween manages to publicly embrace death, make fun of it, even celebrate it. According to Wikipedia, Halloween may originate from an ancient Celtic harvest festival, or it may have entirely Christian origins. As a rule, if Wikipedia doesn't know, nobody knows. But wherever Halloween came from, occasions to remember the dead and remind ourselves of the finitude of existence are a good way to raise one's spirits. And that is what Wiggle Soup is all about. Terrible puns. As far as life events go, death must be one of the most significant, and certainly the most assured. So what is it about the topic that makes us feel so uneasy? Subtle reminders of death, like photographs of departed relatives, adverts for health insurance, and the sight of graveyards, cause people to cling tightly to the religious views of their community. This may be instinctual, but it's not always desirable. Vulnerable people have been known to aggressively defend their beliefs against outsiders to strengthen the group they associate with. I suspect that if people could actually accept their final, ultimate, and complete mortal end, this might lead to a reduction in prejudices, discrimination, hostility, even terrorism. Don't worry, I don't intend to get too political with this podcast. I'll try to keep it light. With any luck, a gentle reminder of death may just inspire us to reevaluate what really matters in life. Personally, coming to terms with the scientific reality of my own demise, and the quirks of anthropology, make it easier to stay skeptical of socially imposed goals like the pursuit of money, status, and fame. Confronting mortality ought to focus our attention on more life-affirming experiences, on nurturing meaningful relationships, and on questioning dogma wherever we find it. At least that's the hope. Studying forensic science will teach you a lot about the mechanics of death. I was taught, and reluctantly shown, that death follows predictable stages based on temperature and humidity. For example, the first thing that happens to a fresh corpse involves carbon dioxide. This gas, trapped in the blood, creates an acid which destroys cells. Enzymes get released that then break down the body from the inside out. With the immune system offline, our body's faithful community of microbes run riot, decomposing us even further. Over a month or so, gas builds up until the body itself bursts. Once all the flesh has been converted into a nutritious, wiggling soup for the next wave of recyclers, decomposition ramps up until only clothes, bones, and hair remain. These can kick about for hundreds of years, potentially. The cycle of life, aka the carbon cycle, is a grotesquely beautiful thing, but it doesn't explain death. Why are lifespans so variable in nature? And why do things have to give up the ghost at all? We need to know what an individual, or an individual's genome, gains by dying. It's fascinating how a mother octopus will voluntarily starve to death watching over her first and final clutch of eggs. Male praying mantis will deliberately gift themselves to a mate as a snack. Whole populations of salmon will expire from pure exhaustion in one single spawning frenzy. None of these fates are accidental. All of them are methodical and calculated, genetically speaking. and makes perfect sense in the light of Darwinian natural selection. Once we see that death itself evolved, we can unearth its benefits. A big clue to the origin of death lies inside our cells. All complex cells, right across the tree of life, use the exact same process of deconstruction when it's their time to go. In all its fiddling intricacy, scheduled cellular death has been meticulously preserved over evolutionary time, right back to the most archaic algae. Ever since life began, all free-floating cells have been vulnerable to viruses. Having reproduced quickly in the presence of food, individual algal cells abruptly kill themselves before they can be hijacked by viral invaders. When an enemy like this effectively learns to become more contagious, swift emergence followed by mass suicide has proven to be a pretty effective defense. Taking your metabolic secrets to the grave is better for the next generation of free-floating cells than letting them fall into the hands of a virus. Even today, a suitable threat can trigger the spontaneous suicide of an entire algal bloom. Out here on the furthest branches of Darwin's tree, each cell in our bodies retains the ancient ability to self-destruct. Only now, cellular lifespan depends on what job the cell is doing. Blood cells, for example, turn over fast to maintain the circulatory system's oxygen-carrying efficiency. Old, tired cells get forced into early retirement. Brain cells, on the other hand, are exceptional, as they can last our entire lives. As cells like these serve as the basis for all memory and learned experience, their unique network of connections are utterly irreplaceable. In most cases, though, survival prospects for the whole organism improve if sick or damaged cells are swiftly eliminated. For this reason, the invention of death may have made multicellular life possible. So death has a practical side, but cell turnover doesn't explain the limited life expectancy of an entire organism. Consider the sea anemone. Some species are theoretically immortal, as they can replace their cells indefinitely. Why isn't this true for all creatures? Well, because even a truly unaging, biologically immortal creature would be lucky to live forever. Statistically, given enough time, everything will fall prey to a deadly disease, predator, natural disaster, or some bodily malfunction. Your prospects depend on your lifestyle, and vice versa. For all their limbs, an octopus is largely unarmed. Soft, squishy, and delicious to predators, octopus have many natural enemies. They have no incentive to maintain impeccable fitness forever. Instead, a mother sacrificing herself in defense of developing larvae yields far better results than abandoning them to search for another mate. Some organisms, like the female praying mantis, lay more eggs if they are well fed. If you happen to discover that you're a male mantis, surrounded by mortal enemies and with very few chance sexual encounters, strategically feeding yourself to a lover is in your best genetic interests. Suddenly, given the unique challenges facing each species, the evolution of all these behaviors is not so surprising. Because energy is always limited, the cost of bodily repair, replacing old cells, must be subtracted from the energetic costs of reproduction. Organisms that try to do both simultaneously will fare worse than those who ration their resources. If, however, you're a salmon with only one opportunity to procreate, throwing all your life savings into that single, heroic, frenzied orgy is exactly what a family planner would recommend. On the whole, humans have fewer threats and more opportunities to mate than salmon, manatee, and octopuses. For most people, orgies are a seminal party, not seminal parity. God, that was bad. Our natural history has favoured the production of a few children spaced out over a longer lifespan. Perhaps it's this small clutch size and generous 70 years and 10 that make death so abhorrent to us. Lots of socially intelligent species show a morbid fascination with death. Crows and elephants, in particular, are intensely curious around a familiar carcass, if not tragically attached. When such behaviours become elaborate and formalised as they do for chimps and whales, we call it mourning. Humans go even further. Recognising the link between a rotting corpse and sickness, early humans adopted a culture of strategically abandoning the dying or departed. This is different from the other great apes, who tend to leave loved ones where they fall. And the practice created an interesting divide. To those first early human adopters, it would have suggested that the dead have no place among the living. The next step for our ancestors was to assign the deceased somewhere to go, physically, not spiritually, though that would logically follow. Funerary caching is simply the purposeful stashing of spent bodies. This needn't be underground or in an individual plot. Generations of hunter-gatherers ended up in communal holes, caves, lakes, or other select locations away from those with a pulse. Allocated muster points for the dead turn up all over the world as humanity fanned out. Given their own dwellings and plenty of company, it can't have taken much for people to assume that social agency persists after death. Deliberate mass burial creates the impression, even the expectation, of a life hereafter. From then on, human funeral rituals have blossomed into spectacular displays of symbolism and social theatre. For better or worse, even these tens or hundreds of thousands of years later, there is absolutely no hard evidence to indicate that a person's immaterial essence, memories, or persona survive the ravages of decay. Scientists may be clueless as to exactly how the brain gives rise to subjective conscious experience, but resorting to supernatural explanations seems fatally flawed, as we saw last episode. There's no good reason to doubt that brains produce the self, as we perceive it. And brains are made of cells, and cells die and decompose. Many people are bound to feel a bit disappointed by this, myself included, but that doesn't make it untrue. Even so, consolation through union with our loved ones in an immortal, disembodied afterlife might actually be a scientific fact that we can demonstrate. Not in the way you want, but in the way you think. I'll try to explain. It's a profound truism that every skill you've learned, conversation you've had, idea you've developed, memory you've recalled, in short, anything you've ever done, has physically changed your brain. All our actions and experiences make permanent neurobiological renovations. If you can remember any of the animals I've mentioned so far in this podcast, it's because new connections have been made among the tangle of cells in your brain. My neurons did that to your neurons. You're welcome. However we live our lives, the fancy dress, the orgies, the dark secrets, every event tinkers with your unique personal network of brain cells. As this is the basis for human memory, it applies across the board, from the feelings we have for people to the in-jokes we share with them. Every teacher we loathed at school, every friend whose birthday we forgot, every boss we managed to impress, every hopeless colleague, every ex-partner and cherished family pet has incrementally sculpted our brain and influenced how it operates. Neural plasticity, as it's called, also explains how and why our personalities change as we age. None of our values, opinions, preferences, or general inclinations are permanently set in stone. This is a problem to wrestle with if you believe in an immortal soul. Not so for neuroscience. It blows my mind to think that our memories of people are as real and physical as the etchings on a headstone. Anyone that has ever made an impression on you, no matter how large or small, has reshaped your brain forever. And you've altered the architecture of their brains in return, an effect that will haunt them long after your biological death. What all this means is, we exist just as literally in the brains of everyone who can remember us as we do in the room that we're sat. We are diffuse in this respect, not confined to one body. The impacts people have on each other are far-reaching and impossible to erase. Our influence lives on, even after death, in the living memory of those who knew us. While we're alive, what we think of as ourselves, our memories, emotions, thoughts, fantasies, ambitions, and ideas, are just a unique cobweb of neuronal connections. We continue to exist even after death in the same form, except as cobwebs in other people. As long as we are remembered, we still truly exist as an arrangement of living brain cells, which is all we ever were in life. What we leave behind is not just a momentary snapshot of us in any one moment, but the sum total of all the influence we have had on other people. It all exists, immortalized in the minds of those who remain. The impressions people leave on each other live longer than the people themselves. So what better reason to let go of your grudges, stop playing the victim, and make sure good memories are all you possess and all you leave behind. Well, I've definitely got more to say on this subject, but it'll have to wait for next episode, as this instalment has reached the end of its natural life expectancy. Again, thank you for listening, and I hope that I've left your brain cells altered in the best possible way.